In this example, we will do a pretty simple problem to illustrate the notion of current divider. Okay, so what we have here again is a circuit that has resistance R1 and R2 connected in parallel. R1 is a big resistance with 5 kilo ohms. R2 is a smaller resistance with 1 kilo ohm. Okay, and there is a current IS, right? There is a current IS of 6 ampere magnitude. Okay, what we want to do is really find out the current that is flowing in the resistance R1. So find out I1 and how much current is flowing through this resistance. So that's I2. We want to find out the values for I1 and I2. Just like we did for the voltage division problem, let us start by guessing through intuition. Okay, R1 is a bigger resistance, so I1 should be a smaller current. Okay, bigger resistance has smaller current, and smaller resistance R2 has a current I2 that is bigger. Okay, the same reason we discussed traffic, right? If there is more traffic lights, the number of cars down that lane is small. If the stoplights and the number of speed bumps is small, the road resistance is small, the number of cars is going to be high in that lane, intuitively speaking. Okay, so bigger resistance has smaller current, so that's the bigger resistance has a smaller current, and a smaller resistance has a bigger current. That's what we would expect to see. Let us see if that is the case or not. Okay, let's really see if that's the case or not. And in order to do that, we want to use the current division method, right? So in the current division equation is I1 is R2 by R1 plus R2 times IS. Remember, that's the formula that we just saw from current division. Okay, so we plug in those numbers. R2 is 1 kilo ohm by the sum of R1 and R2 is 5K plus 1K ohms. And then of course the I source is 6 amperes. You will see that I1 is going to be 1 ampere. So this is 1 ampere. Okay, plug the numbers in. Let's do the same math for I2 as well. I2 is R1 by R1 plus R2 times IS. Plug those numbers in. 5 kilo ohms, that's the value of R1, by 5K plus 1K, that's the sum of the resistances, times 6 amperes. So you get a value of this 6 cancels that 6, you get a value of 5 amperes. Okay, so clearly, so this guy is 5 amperes, I1 is 1 ampere, and I2 is 5 amperes. So pretty straightforward, much like we expected, right? I1 corresponding to the larger resistance is small compared to I2, which is 5 amperes, and it is flowing through the smaller of the resistances. The smaller resistance carries a larger current, larger resistance carries a smaller current when they are connected in parallel. Okay, that's the current divider example. Pretty simple example.